Hello everyone, welcome to another episode from Chedexcel. So today in this video I'm going to talk to you about the periodic patterns, or we call them as periodicity, right? So in unit 1 chapter 2 we have the periodic patterns or the periodicity. We have to know a certain properties of the elements, and depending on their place in the periodic table, their properties get changed. In the previous video I discussed about the periodic table, and you can watch that as well in this pop-up banner, or you can use it from the description, right? Anyway, so we'll talk about the periodic patterns today that you have to know in unit 1. So periodic patterns, or we commonly call them as periodicity, and here I'm going to talk about 6 main parts on that. So those 6 parts are variation of the atomic radius, variation of the ionic radius, variation of the first ionization energy, variation of the successive ionization energy, variation of the electronegativity, and the variation of the melting point. So those 6 features or those 6 properties I'm going to discuss under this chapter. So in this video we'll be talking about the first 3, and another video I'll discuss the remaining 3, right? So we quickly go to the first part, that is the variation of the atomic radius, right? Now when you talk about an atom, atomic radius is defined as the distance between the nucleus, right? So if I use a different color here, we define the atomic radius as the distance between the nucleus and the outermost main energy level. R is what? Atomic radius. R is atomic radius. So that's what we define as the atomic radius. So this atomic radius depends on 2 features. One is the nuclear attraction, or we call them as nuclear charge. The second one is shielding effect. So we'll see one by one what are those features. First one, nuclear attraction. So what is nuclear attraction? The nuclear attraction or the nuclear charge means the ability of the nucleus to attract electrons. That depends on the number of protons present, because the nucleus is positively charged. If the nucleus has more protons, it can attract electrons much easier, because higher the number of protons, greater the nuclear attraction or nuclear charge we say. So that is the first feature. So generally higher the number of protons, stronger the nuclear attraction. The second one is shielding effect. Now at once we get the idea that shielding effect is something really good. It covers or it protects. That's the first impression that we normally get into our mind, shielding effect. But actually what the shielding effect means is in unit 1 is, now the nucleus is there. Around nucleus we have main energy levels. Now when there are electrons in the inner main levels, right, when there are electrons in the inner electronic shells, the electrons in the outermost level, they don't get that much of nuclear attraction, because the protons in the nucleus tend to pull electrons, but the inner electrons present, they tend to gain most of that attraction. So the nuclear attraction field by the outermost electron is shielded, we say, or is covered due to the presence of electrons in inner energy level, due to the presence of electrons in inner energy levels. So that we say when we go down the group, or when the number of electronic shells, main energy levels increases, the shielding effect increases. Now with that particular thing, sometimes we call the shielding effect as the repulsions present among the electrons. That also fine, but in AS we normally write like shielding effect is the covering of the nuclear attraction from the electrons present in the inner energy levels. So there are 2 things like that, nuclear attraction and the shielding effect, which governs or which determine the atomic radius, right? Now the first thing to remember is the very first note or the theory part under atomic radius is, first one is always atomic radius decreases from left to right of a period. Always atomic radius decreases from left to right of a period. Let's say Y, which means from sodium, magnesium, aluminium, silicon, like that. If the size of sodium is this much, magnesium is slightly smaller, aluminum is even smaller, silicon is even smaller. So it's like that. From left to right of the period, atomic radius decreases. Sometimes they ask it directly, sometimes they ask explain the atomic radius between silicon and sodium. So they are asking the same thing there as well, right? Let's see why atomic radius decreases from left to right of a period. Now, when electrons are being filled into the outer shell, we say from left to right of a period, electrons are filled into the electrons are filled into the same main energy level, so that we say their shielding effect remains the same. But number of protons increases. So as the number of proton increases inside the nucleus, we say their nuclear attraction increases. So nuclear attraction increases, shielding effect remains the same. So we say the effective nuclear attraction or effective nuclear charge, or other way around, how effectively the nuclear attracts electrons increases. So when the effective nuclear attraction increases, the outermost electron cloud or the outermost shell tend to get contracted towards the nucleus, which makes its atomic radius to decrease. So don't get the idea that when the mass increases, size should also increases. It's not like humans. When the mass is high, we just have it's a fatty person. Not like that. When the size of the atom, when the mass of the atom increases, sometimes from left to right, if you are considering, always the radius of the atom decreases, right? So atomic radius decreases from left to right of the period. So what are the 3 points we write? Electrons are filled to the same main energy level, so that their shielding effect remains the same. Number of protons increases, so the nuclear attraction increases. Therefore, effective nuclear attraction increases, making the atomic radius to decrease, right? That's the first thing. Left to right of a period, atomic radius decreases. What happened from top to bottom of a group? Always, when going down the group, always top to bottom of a group, atomic radius increases. Top to bottom of a group, atomic radius increases, right? Then potassium, rubidium, cesium, like that. Potassium would be even bigger, cesium would be even bigger, like that. Down the group, atomic radius increases. Why is that? Down the group, always new main energy level is added. When a new main energy level is added, their shielding effect increases, because inner electrons gain more nuclear attraction. So shielding effect increases, which makes the nuclear attraction to decrease. Therefore, atomic radius increases. Now, when going down the group, also the number of proton increases. That's true. But we say the effect of shielding effect is much higher than the influence of the protons inside the nucleus. So when going down the group, shielding effect increases. As a new shell is being added, nuclear attraction decreases. That makes the atomic radius to increase. So when you talk about the atomic radius, always left to right of a period, atomic radius decreases. Top to bottom of a group, atomic radius increases, right? That's the first part. Second one we are going to talk about in this periodicity is the variation of the ionic radius, right? Let's see how the ionic radius vary in an atom, right? Okay, so variation of the ionic radius. So ions are formed by removing and gaining electrons. So when you talk about the ions like this, if I take N3 minus, O2 minus, F minus, neon, I just keep neon as well, it's not an ion, sodium plus, Mg2 plus, Al3 plus. So when you talk about the ions, electrons are removed to form cations or the positive ions, electrons are gained to form the negative ions. When you talk about the atomic number, that is 7, 8, 9, 10, 11, 12, 13. Depending on the number of electrons removed and gained, if we talk about the number of electrons, this is 10, this is also 10. So all of them have same number of electrons. Having the same number of electrons doesn't mean that they have the same radius. Why? We have to consider about their protons as well. Number of electrons same means they have the same shielding effect, because electrons are filled in a similar way. So shielding effect would be the same. But again, we have to think about the nuclear attraction as well. So if we talk about the number of protons they have, here it's 7, here it's 8, it's 9, here it's 10, it's 11, 12 and 13. Now number of protons are different, number of electrons are the same. The ions or the atoms with the same number of electrons, we call them as isoelectronic. Always they ask us to compare the electronic atomic ionic radius of isoelectronic ions, ions with the same number of electrons. Now if you just come to here, in this case, in this particular one, 7 protons are there to keep 10 electrons. In this case, 13 protons are there to keep 10 electrons. So in nuclear attraction wise, keeping 10 electrons using 13 protons is much easier than keeping 10 electrons from 7 protons. So the idea is, higher the number of protons, greater the nuclear attraction. So it is easier to keep the electron cloud, which means the ionic radius decreases with cations. Why? Cations usually have, or cations always have, more protons than electrons. So when you talk about the ionic radius, we have to think about the number of electrons and the number of protons. Higher the number of protons, greater the nuclear attraction, smaller the ionic radius. So when you compare the N3 minus and Al3 plus, N3 minus has the largest radius because it has only 7 protons to keep 10 electrons. But here in Al3 plus there are more protons than electrons, so the effective nuclear attraction is much greater with Al3 plus. So when you write the electronic, the patterns, N3 minus is the largest, O2 minus, F minus, so it varies like this. So it varies like this. So we can say ionic radius increases this side. Ionic radius increases. So we say ionic radius increases from left to right like this. So generally we say larger the anion, negative charge, larger the radius, larger the cation, smaller the radius. So I remember this one like negative ion, anion. It says if something is more annoying, larger the trouble. So larger the annoying, larger the trouble. Likewise, larger the anion, larger the radius. So obviously the opposite. Larger the cation, smaller the radius, right? So this is how the variation of the atomic radius and the ionic radius, right? So in the next video, we'll discuss how the first ionization energy and the successive ionization energy changes. So I hope you can get an idea about how atomic radius and the ionic radius varies, and if this is helpful, give us a thumbs up and consider subscribing. Thanks for watching.